prove that divergence of phi is a scalar function or scalar field and A is a vector function or vector field. So divergence of phi A is equal to phi into divergence of A plus dot product of A and gradient of the scalar function phi. Always remember, when you take the gradient means gradient of a scalar function, and when you take the vector field, that is called the divergence. Divergence is always for a vector field and gradient is always for a scalar field. This can be written in del operator like this. Divergence of phi A can be written as del dot phi A. Divergence can be written in terms of del operator, and in the right hand side phi divergence of A means del dot A plus A vector dot gradient of phi. Gradient of phi means del of phi. Here you see del of phi, this is the gradient, and when if phi is a vector field, then that will be divergence. Since here phi is a scalar field, it is gradient. We have to prove that del dot phi A equal to phi del dot A plus A dot gradient phi. Here the vector field A equal to, suppose vector field is equal to I cap Ax plus j cap Ay plus k cap Az. So what will be phi into A? Phi is a scalar field, so it can be multiplied. So phi into Ax I cap plus phi into Ay j cap plus phi into Az k cap. So what will be the divergence of phi A? This on the left hand side we have divergence of phi A. So divergence of phi A is equal to del dot phi A, and we know del operator is a vector operator and can be written as I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z with the dot product of phi A vector. Phi A vector means this one, that is phi x I cap plus phi ay j cap plus phi az k cap. I have written here. So what will be the dot product of this del operator with this vector? When you take the dot product, only you have I dot I, j dot j, k dot k. They are one. So for the first term, you have phi into partial derivative of ax with respect to x plus ax partial derivative of phi with respect to x. For this term, when you take the partial derivative of this term with respect to x, you will get these two terms. Similarly, if you take the partial derivative of this phi ay with respect to y, that will be equal to phi partial derivative ay with respect to y plus ay partial derivative of phi with respect to y. Similarly, if you take the partial derivative of phi az with respect to z, that will be equal to phi partial derivative of az with respect to z plus az partial derivative of phi with respect to z. Now you rearrange the terms. If you rearrange the terms, then you will get, you take phi common from here, from here, from here, and from here. If you take phi common, in the bracket you have partial derivative of ax with respect to x plus partial derivative of ay with respect to y plus partial derivative of az with respect to z. Then the other three terms, this term and this term, I have written here. Ax partial derivative of phi with respect to x plus ay partial derivative of phi with respect to y plus az partial derivative of phi with respect to z. And you see this term, this is phi into this term, this is nothing but phi is a scalar, so you take it outside, and this is nothing but del dot A. If you take the dot product of del operator with the vector A, then you will get this. So this one will be del dot A. Then what will be this one? This one can be written like this: I cap Ax plus j cap Ay plus k cap Az dot I cap del phi by partial derivative of phi with respect to x plus j cap partial derivative of phi with respect to y plus k cap partial derivative of phi with respect to z. Okay, if you take the dot product of this and this, you will get this, and this is nothing but the vector a. This is the vector a, and this is nothing but del of phi. That means this is the grad phi. In this way, you can prove in the left hand side you have divergence of phi a or del dot phi a here, that is equal to phi del dot a. That means the gradient, the divergence of a. This is the divergence of a plus the dot product of a vector with the gradient of phi. Okay, this is a very important relation. Sometimes it is asked in the examination to prove that divergence of phi a is equal to phi divergence of a plus a dot gradient of phi. You should remember also this relation. This is very useful relation in physics.